All right, so in this video, we're gonna solve another um, problem, a difficult problem that is involving systems of linear equation. So the equations are like this: um, x to the power of y, wait, x to the power of y equals y to the power of x minus y, and the other one is x to the power of x equals y to the power of 12y. And yeah, so this is a system of linear equation. And we are going to find all positive real numbers, x and y, that satisfy the following, or the following system of linear equation. So x to the power of y equals y to the power of x minus y, and x to the power of x equals y to the power of 12y. All right, so to solve this, we are going to use a natural logarithm in order to put the exponents at the side of each expression. So x to the power of y, I'm gonna put a natural logarithm so that later on we won't have a problem with exponents. Okay, so next is we're going to, so by the way, so this is, it implies, yeah, so we're gonna put the exponents at the side. Y ln x equals x minus y ln y. The same here, x ln of x equals 12y ln of y. Wait, 12y ln of y. All right, so next is we are going to um we're gonna change this one into ln x equals something. So we're going to change we're gonna divide both sides by y, so that it will become like this: ln x equals x minus y ln y all over y. So what we did there is we divide both by y. And now, since we know that ln x is this, ln x is this, x minus y ln y all over y, we can substitute it here. Okay, so we're going to substitute it here. So it becomes, so the ln x will become x minus y ln y over y. Okay, equals 12y ln of y. So we just substitute based on the what we have solved on top. So since ln x is this, then we substitute it here. Okay, so let's remove those checks. Now we're gonna simplify this further in the second equation. We're going to put together those, wait for a while. Let me uh emphasize the ln y, so I'll just put the over y in x times x minus y. Anyway, it's still the same. Okay, I will just emphasize that because I'm going to factor that out later. So I'm going to transpose x times x minus y ln y over y. Transpose this other expression on the other side, so the other side will just be only 0. So the reason why I do that, because I want to factor out the ln(y). So that's the reason why I want to emphasize the ln of y. So let's factor out ln(y). So this will be x times x minus y over y minus 12y. And then enclose with parentheses ln of y, because we factor out the ln y. Now let's continue. So we don't have enough space, so I'll just move to the next slide, and we're gonna copy the last part that we wrote, x times x minus y what was that, x times x minus y over y minus 12y ln y equals 0. All right, so using this expression, we are going to formulate a formula. So for this to be 0, so it's either the ln y equals 0, or this one is equal to 0, or it can be both. Of course, if any number 2 times 0, for example, is 0, or 0 times 0 is 0. So as long as one of those multipliers is equal to 0, then this statement will be true. So we can assume that let's say if ln y is equal to 0, so that means so if ln y equals 0, and given that we have an expression, okay, so we have this, by the way, okay, ln x equals so let's rewrite that, x minus y ln y over y, x minus y ln y. Okay, so I'm going to rewrite that here to emphasize. All right, so because this is connected to this, so if ln y equals 0 according to this, so meaning if this is 0, then the ln x will automatically be 0, because whatever is x minus y over y, as long as this is 0, automatic the whole thing is 0. Okay? So if ln y equals 0, ln x is also 0. So for ln y equal to be 0, the y must be equals 1, because ln 1 equals 0, and also x equals 1. Okay, so that's the first solution, x equals 1 and y equals 1 and x equals 1. So that's the first answer to our problem. Now we have another we have another solution or answer, because we haven't considered the other side. We only consider the ln y. Now let's consider the other one. the x times x minus y over y minus 12y. So we are going to consider it equals 0. So as I said, there are two things to consider. The ln y equals 0, and the whole expression x times x minus y over y minus 12y, it's equals to 0. So if that is equals 0, then we can multiply all by over y. Oh wait. Yeah, we can distribute for our first. So we can distribute this as x squared minus xy minus all over y minus 12 equals minus 12y equals 0. Or we can separate this into over y and over y. It's the same. So anyway, we can cancel the y. So it's only let's continue to the next slide. So what's left is x squared over y minus x minus 12y equals 0. X squared minus x minus 12y equals 0. Next is I'm going to divide all by or multiply all by 1 over y, so that this y is gone, so that the 12y will just be simply y. So this will be x squared over y squared minus x over y minus the y will be cancelled, so it's minus 12 equals 0 times 1 over y is 0. Then we can factor this. Can factor this as x over y minus 4 x over y plus 3 equals 0. So why is it like that? Because if you're going to do x over y, because that's square of x squared x squared over y squared, and then negative 4 and positive 3, if you're gonna cross multiply that, it's negative 4 over x over y, sorry, and positive 3x over y. So if you combine that, that's negative x over y, which is the same as this. Okay, so that's the reason why it is a correct factor. Now we cannot consider this. Wait, let me show you first both. X over y minus 4 equals 0. So let me erase this sketch. I think I need this space later. Or x over y plus 3 equals 0. So we're gonna solve this first. X over y equals 4, transpose to the other side. Then cross multiply x equals 4y. Here, x over y equals negative 3, x equals negative 3y. Now we're gonna take the ln x both. Okay, so I'll just continue here. Ln x equals 4y, while the other one is ln x equals, so, oh wait, sorry, ln x of equals ln 4y, because we take both ln, while the other one is ln x equals ln of negative 3y. Now we will not consider this one because it's ln of negative, so we will not, and knowing that y is positive number based on the given, based on the problem. So positive times negative 3 is surely a negative, so cannot have a natural logarithm of a negative number, so we will remove that. now we will just retain this and solve this. Now ln x equals ln 4y. So we have as I've shown you a while ago, this one, we're gonna use this again. ln x equals x minus y over y ln y. So based on this, we're gonna substitute ln x equals ln 4y. So ln 4y, so this one, the ln x will become ln 4y. So that means the x is the 4y. And the x here will become 4y minus y over y ln y. So ln 4y is equal to 4y minus y is 3. So this is 3. 3y, by the way. Cancel the y, so it's only 3 ln y. So ln 4y equals 3 ln y. Now, we're going to put this 3 to the top as an exponent of y, ln y cubed. So why I want to do it like that? Because I want to remove the ln, or the natural logarithm. So ln of 4y and ln y cubed. So let's remove the ln. So it's only 4y and y cubed. Divide both by y. So we have 4 equals y squared. So that means y is 2 or negative 2, but then we will not consider negative answer based on the problem that it's only positive numbers. We're going to find for positive numbers. So only y equals 2. So since we already have y equals 2, and we have here x equals, so by the way, we have ln x equals ln 4y, and here x equals 4y. I forgot to write it. So that's why we are substituting x as 4y. So based on this, x equals 4y. So we can substitute x equals 4 times 2. So x equals 8. So there are two sets of answers. The first one is x equals 1 and y equals 1. The second solution set is when x equals 8, y equals 2. So those are the two set of answers for this problem.